Okay, let's talk about the engineering of this cover. Now, my plan is to have a smaller piece in here that can slide back, and then I can put my purse into the lower area under here, because there's a space here. Because of the ductwork, there's a space to put my purse. So eventually I want to have that come out and allow me to put my purse here. Apart from that, I also want to just talk a little bit about this piece of wood here and being able to assemble and disassemble the car, not just while I'm making this console, but if I need to access any of the parts underneath later on. I don't want to assemble this once and then it's kind of like glued together and impossible to get back apart. So it needs to be engineered to be able to be taken apart. Now, the jewelry box here, move the mug. The jewelry box is it's a little tilted, so there's a gap here. I'm fine with that. It's a little strange, but I'm fine with it. I'm thinking of printing 3D printing something that'll close up that gap and make it look a little bit more aesthetic. I'm going to worry about that later. But the point is, in the back here, the wood is all the way touching. I can make pictures of that, but I'm not going to worry about it right now. I just want to show you one of the problems here. Taking this out, if I slide this back, it gets to a point where it's stuck. And the reason that is because this is actually shaped like this. It's hard to see from that angle, but it's shaped very much like that. And so when I pull it back, the narrower part binds on this piece. If I lift it up, I can take it out. So it is possible to take it out there. But it's tricky because the fact that this is not square. Now I have these little pieces of trim that finish off this edge to make it look nice. For those who don't know, trim is used to cover up bad workmanship. So things are not always cut square, not always cut perfectly, and trim makes it look a lot better. So I cut this without a jig. I'm actually probably going to remake this piece. But bottom line is, this trim finishes this off so that you don't see the seams at all, and it looks a lot nicer. And the nice thing about it is this trim clears the bottom, so when I lift this up, if I lift the whole thing up and pull it out, it will come out with the trim on it. And sorry, I'm hitting the camera. So that narrow problem is the trim does not affect that, which I'm very grateful for. Anyway, so the issue of taking this in and out is tricky. One solution to that, if this couldn't come out and slip out from underneath here, one solution to that is to install this first and then install this, the jewelry box. So the order of putting things in can be important in the engineering of how this goes together. Luckily, it looks like I can get away with taking this out without removing the jewelry box, but it's kind of in my mind. I would like to engineer it so I can do that and not have to put this first and then the jewelry box, and that's my only choice. So anyway, with that said, the upshot of the whole idea, what I want to try and convey here, is the fact that I'm going to be putting the T-service in here, and I'm going to be having a hole in the bottom for the piping to come up, for the hot water to come in here. How to get that piping in there is going to have to be engineered. It has to be engineered in particular around how this is going to be assembled and disassembled. So if I need to be able to pull this out with this installed and the line installed, then maybe the hole that goes through here is actually U-shaped so that I can pull this out and it goes around that piping. So I need to plan for that. Similarly, when I take this jewelry box in and out, how do I attach the piping to this in a way that seals against leaks, but can be assembled and disassembled? So that is what I'm going to be designing today. Now, what I have here, I have a number of options that are kind of interesting. Let me take this out so that you can see the boiler. and it's binding. There we go. Okay. So again, here's the boiler. The silicone tubing is meant to withstand the hot water and steam. I got these stainless steel straws, which are collapsible. So this is an option that I have. I'm kind of excited about this one. Also because it's much narrower than this. I'm not concerned with this being too hot for wood, which you got to think about these kinds of things. But this will have only hot water in it. If this were ever to get hotter than the temperature of hot water, this is the source of the heat. This would have that problem, and this already has at least one fuse in it. I have another one that has 2 fuses in it, so this has a protection against overheating. And I will probably, actually no, it has, this one is the one that has 2. There's 2 fuses here, one on the in and one on the out. Anyway, so I know that there's no way that this could become hotter than boiling water. It'd be a little bit hotter because steam is hotter than boiling water, but only slightly enough. It won't be Fahrenheit 451. Won't be enough to burn wood. Anyway, so that is those are the issues that I'm dealing with. The fact that I want to be able to dismantle this multiple times if I need to. How that relationship in dismantling and assembly, the relationship between the cover and the jewelry box and the boiler. So yeah, I just thought I would let you know all that's going through my mind. There you have it.